Hi students, welcome back. In today's video, we'll be tackling a classic Leetcode problem, merging two sorted lists. The merge process in this problem shares a key concept with the merge sort algorithm. Okay, let's get started with understanding the problem statement. So here is the question. So we are given heads of two sorted linked lists, list 1 and list 2. Okay, we have to merge the two lists into one sorted list and output the head of the sorted list. So if the input is 1, 2, 4, 1, 3, 4, so first element is 1, 1, 1 appears twice because it is there in both the lists, then 2, 3 and the two fours. So if both the lists are empty, output is empty. If only one of them contains elements, the output also contains one element. Okay, so let's go over the solution with a example. So what should be the head of the resultant list? Ideally, it can be either 1 or 2. How do we decide whether it is 1 or 2? We just pick the smallest because we want the sorted list. So instead of having this condition of figuring out which is smaller and starting with the smaller one and having not null checks and all, we will follow what is called a dummy head approach. Dummy head is nothing but we will create a dummy node. The value of it doesn't matter. We will just create a dummy node which will be the start of our resultant list. So the result would be the next of this dummy head. So at the end of it, we will just take the next of it. Okay. So then we will need a current pointer. Okay. Initially, the current pointer will also be here. Okay. Okay. Initially, the current pointer will also be here. And we will need a pointer for list 1. Okay. It will be obviously pointing to the head of list 1. Similarly, we will need a pointer for list 2, which would be here to start with. Okay. So we have a dummy head, which is this one. We have the current pointer of our resultant list. Okay. And we have the list 1's pointer and list 2 pointer. So when we start, we are at the current. We have to figure out what is the next of this current. What will be the next? Whichever is smaller of the list 1's head and the list 2's head. Okay. So in this case, 1 is smaller. So our dummy heads next will point to 1. Okay. And since 1 is already in our resultant list, our 1 pointer will move forward. Now, when we are our current pointer will move to this one. Okay. Now, when we are at 1 or when we are at the current node, we have to decide which one is next based on the heads of the current positions of list 1 and list 2, which is 2 and 3. So 2 is smaller. So currents next will point to 2. List 2 will move forward and current will come here. Then at this node, at this current node, we have to decide what is next. Both are same. So list 2 will just move forward. Current will come here. Okay. And now we have to decide for this current node, which is the next one. Will it be 3 or 6? So it will obviously be 3. So 3 will point here and list 1 will move forward. Current will go to this 3. Okay. Now 3 is already the smaller one compared to list 1 and list 2. Okay. So it is already pointing there. So we will just move forward and bring the current here. Okay. Now this current node, what should it point to? List 1 or list 2? Both of them are same. So it doesn't matter. Let's go ahead with list 1. Okay. And current comes here. Now for this current node, should it point to list 1 or list 2? 6 is smaller. So it should point here. Now list 2 goes forward and current comes here. Okay. Now for this node, what should be the next one? Obviously 7 is correct because 7 is smaller. So we just move the list 2 forward and current comes here. Okay. For this current node, what should be the next one? Okay. So list 1 is 8, list 2 is 9, list 1 is smaller. So it goes here. Okay. list 1 there is nothing left, so list 1 would be null now. So when when one of them is empty, what do? We just populate the next to the remaining elements of the list. Okay. If list 2 has more elements like 10, 20 and all, it will still be chained here. So if we just point this here, it should be enough. So we will just point the last element to the last element means our current to the remaining of whatever list which is not null. So our answer would be dummy head dot next, which would be this head, and the pointers are rearranged like this. It would be 1 2 3 3 3 6 6 7 8 9, which is sorted. Okay, so let's go over code for this. Okay, so here what are we given? We are given a class called list node which has value and next, which is a standard linked list definition. So what do we have to create first? We have to create a dummy head. Okay, for the dummy head, value doesn't matter. So let's keep it at 0. And what else do we need? We need a current pointer. To start with, it is at dummy head. Okay, and we need list 1 and list 2 and we iterate over them. So while list 1 not equal to null and then list 2 not equal to null, we check if list 1 dot val is less than list 2 dot val. Then what happens? Our current dot next will be list 1 and list 1 should move ahead. List 1 equal to list 1 dot next. Else our current dot next would be list 2 and list 2 would move ahead. Okay, and in both the cases current also should move ahead. Okay, in the final case where one of them reach the end but the other one has elements, we have to capture that. That means if list 1 is not equal to null, then current dot next equal to list 1. Okay, if list 2 is not equal to null, then current dot next equal to list 2. Okay, and what do we return? It's not dummy head but dummy head dot next. Dummy head is a node which we created. Its next is our current head. So let's try to run this and see. Okay, let's try to submit it. Okay, all the test cases passed. Let's see the time complexity of this. So if the lists are of size n, then our time complexity would be, we are passing through this lists in only one loop. So order of n. Okay, this is time complexity. Okay, we are not using any additional space. So space complexity is constant, which is order of 1. Okay, so here using this dummy head simplified the merging process a lot for us. We don't have to check whether dummy head is null. If dummy head is null, then do this. If list 2 is null, all those conditions goes away. Our code becomes more elegant and efficient. So think of this dummy head as a placeholder node that will always remain at the beginning of our merge list. It doesn't contain any actual value. It's just a starting point for our merged list. So the main advantage of using dummy head is that it eliminates the need for all those special cases or conditional checks during the merging process. Okay. Alright then. Thank you for joining me in this tutorial. I hope you now understand the significance of dummy head when solving this merging problems. Remember, practice makes perfect. So keep coding and improve your problem solving skills. If you have any questions, please leave a comment on the video. If you found this video helpful, please don't forget to like, share and subscribe. Happy coding!